Okay, today we're going to be dividing radicals, so I want to bring up the quotient property. Quotient means division. And that means that if I have the radical of A over B, that it breaks down to the radical of A over the radical of B, where A is greater than equal to 0 and B is greater than 0. Now, what this means, and we're going to keep this real simple, and ours are going to break down to where we never have a radical on the bottom. So let's make that statement. We will never have a radical in the denominator. Okay, so my first example I want to work for you guys. Let's do number 1. Radical 17 over 25. So this can break down to radical 17 over radical 25. 17 cannot be simplified. So I'm just going to get radical 17, but 25 can. And that breaks down to 5. Okay? Now we can have another one here where both of them can be simplified. So here I broke it down to a radical over radical. So here are my steps. Break down so that we have a radical in the numerator and radical in denominator. And then after we did that, so we broke it down to a radical in the numerator, a radical in the denominator, the second thing we did was simplify radicals. Okay? Alright, now if you get to a point, you might have to simplify your fractions, but we're just going to leave it to simplifying the radical for now. So the second example I want to work for you. Radical 4 over radical 49 y squared. Okay, so this, we're going to break it down to radical 4 in the numerator, radical 49 y squared in the denominator. Radical 4 is a perfect square, so we get 2. 49 is a perfect square, so we get 7. And y squared is a perfect square, so we get y. Now, for those that don't remember how to do this, remember up here that we get radical 2 times 2, we have a pair so it can come out. And down here we have radical 7 times 7, y times y. We have a pair of 7, so the 7 comes out. We have a pair of y's, so the y comes out. Okay, so just remember how to simplify your radicals. Okay, so let's look at one where we might have to go a little bit further, but maybe not too much. Okay, well, what happens if we have, well, I want to do one where you don't, let's do 5 over 25. Now, one common mistake, don't simplify first. Break this down to radical 5 over radical 25. Okay? Because I have a perfect square in the denominator, and so this is going to give me an answer of 5 over, radical 5 over 5. So, you gotta kind of watch, and let's make a star here. Watch for perfect squares. Okay, now let's do another one. Let's do radical 9 over 3. Okay, now here's one. I have a perfect square, and if I reduce my fraction, I'm not going to get a fraction anymore. So 9 divided by 3 is going to give me radical 3 because it's an it's a quotient problem that goes into it evenly. So my answer here is just radical 3. Okay, so you can do problems like that. So you want to watch to see where you have perfect squares. You want to make sure that if you can reduce before you go in, you don't get a radical, because we will never, let me go back up here to this one, you never want to leave a radical in the denominator, okay? So if I had broken this down to radical 9 over radical 3, then I would have had a radical 3 in the denominator, and I don't want to do that. Okay, so I hope this helps you when you're doing these. Again, look for where those perfect squares are, and that will help you out a great deal.